So I think it's on. Yes. And I'm now shy, and I would like now to share this introduction video with you. Can you see my screen?
Yes.
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 Is the sound on? On?
No, it's not.
I have no idea how it works, but there are subtitles, so that should be fine. So that was the introductory video. I'm not sure if the sound worked well, but it was quite visual, so I guess you got a good idea of what the project is about. And I'll be pleased now to introduce the speakers. So I'm going to share my screen again, but with a slide this time. Here they are. So we'll have 3 speakers, all working in the project. So the first of them will be Maria Luisa Álvarez, who is R&D project manager at URBASER. So URBASER, as you have seen in the video, it's the coordinating organization of circular biocarbon, but it's also a Spanish multinational which is specialized in waste treatment and urban services. And so the topic of Maria Luisa's presentation will be circular biocarbon biorefinery, an opportunity for bio-based materials in Europe. Then we will have Patrizio Salice, from NOVAMONT. So I guess that you all know NOVAMONT. It's an Italian company and world leader in the development and production of bioplastics and biochemicals. So Patrizio is R&D New Materials and Technologies researcher and manager at NOVAMONT. And the topic of his presentation will be bioproducts from urban waste, an opportunity for the bioplastics industry. And last but not least, we will have Joan Colón Jordà, who's a scientific coordinator at the Beta Technology Center. So the Beta Technology Center is a research center on biodiversity, ecology, the environment, and food technology. And it's located in Vic, and it's part of the University of Vic and Catalunya, so in Spain. And so the topic of Joan's presentation will be the sustainability approaches of the circular biocarbon biorefineries. And you can see that there is the moderator here. So myself, I work at ICLEI, as I said, and I'm a circular economy officer, so working mostly on circular economy projects. So that's it for the introduction. I'd like to give the floor to our first speaker, so Maria Luisa, if you like.
Yeah. Okay, I want to share my screen.
Please do.
Okay, thank you, Simon. Hello to everyone. My name is Maria Luisa, and I'm going to present you the circular biocarbon biorefinery as an opportunity for the bio-based materials in Europe. The table of contents, my presentation has been divided in 4 parts. Firstly, I'm going to briefly introduce myself. Then I will continue with the importance of the biorefineries in Europe. Afterwards, I would like to comment about the advantages of biorefineries to the waste management and specifically for cities and industries. And finally, I will give you some information about the future circular biocarbon biorefinery. Okay, as I said, my name is Maria Luisa. I am environmental scientist with a PhD in environmental engineering. I have 6 years of experience as researcher in the biochar field, focusing on treatment of organic waste through various thermochemical processes for its possible valorization. And now I'm working in URBASER as research and development project manager with an active participation in the Circular Biocarbon project. Okay, about the importance of biorefineries in Europe, now increasing efforts are being made to reduce the dependency of the world economy on fossil fuels as natural resource due to the pollutant effects and especially due to the harmful greenhouse gases emissions. With the aim of reversing this damage, bio-based alternatives provide a recycled and limited source of energy and products. For this reason, the European bioeconomy strategy aims to accelerate the deployment of a sustainable European bioeconomy so as to maximize its contribution towards the 2030. Biorefineries and bio-based products are vital in reducing global emissions and decarbonizing our energy system because biorefineries consist on a sustainable processing of biomass into a spectrum of marketable products and energy using a wide variety of conversion technologies in an integrated manner. Nowadays, a total of 803 biorefineries are estimated in Europe by the European Commission, and among them, 506 are destined to produce bio-based chemicals and 141 to composites and fibers. Also, only 136 uses municipal wastes as feedstock. So it's clear that this feedstock is not highly exploited compared to the others mentioned. Among the advantages of the biorefineries to the waste management and specifically for cities and industries, firstly, we can find in general that biorefineries will collaborate in the implementation of the European Green Deal, the European Union Bioeconomy Strategy, and the new Circular Economy Action Plan for Europe. Also, according to the benefits for cities, Biorefineries could offer citizens an alternative integrated management of liquid and solid wastes produced by civil activities. Also, they will generate wealth and employment through techniques that respect the environment and also promote good practices to citizens. According to the benefits for industries, biorefineries could are a marketing opportunity for fertilizers manufacturers because, for example, industries will be able to phase out the use of peat by using these bio-based materials in growing media. Also, biorefineries will guarantee changes in the decision making for new models and management policies because they will support the transitions of several sectors such as industry, agriculture, and transport from fossil fuels consumption to zero carbon emissions. Also, biorefineries lead new links among cities and different sectors, as I mentioned, industry, and agriculture, and transport. However, it's important to note that consumers and the markets are determined to respond to a climate change by altering their buying behavior. But when it comes to price and quality, the end user is very conservative. So additional policy-based market pool is expected to be required to overcome barriers to circular bio-based economy. Okay, now I would like to briefly present you the circular biocarb biorefinery. In this context that I explained, circular biocarbon appears as a flagship type of project in which the first biorefinery will be designed, built, and validated on an industrial scale for the recovery of the organic fraction of urban solid waste and sewage sludge in the high-value final products. These products will be H final products, and well, it's a project with about that last 5 years, and it's a European project that started on June 2021 and is entitled Turning Carbon of Complex Organic Urban Waste Streams into Value-Added Products. The project has a total budget around 23 million euros, of which the European Commission, through the bio-based industry joint undertaking, BBIGU, finances a total of 15 million euros. This is a transnational collaborative project coordinated by, as Simon said, by URBASER, in which 11 partners from 5 European countries, Spain, Italy, Denmark, France, and Germany, participate. The consortium is composed by 4 research and technology organizations, 2 small and medium entities, and 5 large companies. We are URBASER, Socamex, GAP, Femecon Scandinavia, Grafenea, NOVAMONT, Rulier, ICLEI, UVIC Beta, UVA, and Universidad de Verona. The circular biocarbon biorefinery is a unique model in which the process lines will be implemented in 2 different locations, Zaragoza in Spain and Sesto San Giovanni, Italy. In Spain, URBASER in collaboration with Socamex will be responsible for the biorefinery, while in Italy it will be by Grupo CAP. It's designed as it is for for logistical, customer, and market reasons, and also it will support the replicability of the concept by testing it against different waste management schemes, ecosystems, and practices in different territories. Moreover, the biorefinery aims to contribute to provide bio-based materials to industries moving towards their transition to be bio-based. Here we can find the scheme that we have seen in the video. This is a scheme that you can find how the biorefinery will valorize the organic fraction of urban solid waste and sewage sludge into 8 high-value final products. Patrizio will explain the important role of NOVAMONT in the project for the obtaining one of the products, the that is the biodegradable and compostable waste bag. On the aim challenges in the bio-based economy published by European Commission and the European Biorefinery Outlook to 2030 is the following. Currently, there is a lack of evidence on the full life cycle sustainability benefits of bio-based products. Quantitative information on sustainability is needed over the full biomass to product life cycle, including their end-of-life fate to demonstrate their potential environment and other advantages. So today, we will have the opportunity of knowing the important role of UVIC in the project with the impact assessment of the biorefinery, which will give a quantitative information on sustainability over full biomass to product life cycle in the project. So now this is the consortium that I explained before. Well, for more information about the project can be obtained on our website and social networks, Twitter, LinkedIn, and YouTube. So thank you very much for your attention.
Thanks a lot for this really compelling presentation, Maria Luisa. Do we have one or two short questions before we move to the next speech? So I see that Yolanda, you've got your hand raised. So would you like to ask a question, Yolanda?
Yes, thank you. Good morning. Marisa, in your presentation, I have seen that in one of the slides, you said that only a few biorefineries in Europe use waste as feedstock. Why do you think is that? Is it perhaps a question of public acceptance? Or maybe the thing is that there is not an appropriate legal framework. What do you think?
Okay. I think it's more related to the legal framework, because this type of wastes usually have a high presence of inerts and emerging pollutants in their composition. The several physical, chemical, or biological parameters should comply with the legal limits with the aim of providing a high level of human and environmental protection. In this context, it's necessary to make improvements in equipments and processes for the correct management of these wastes, and so to obtain products that comply with the legal and production requirements for future bio-waste materials.
Great.
Okay, thank you.
Thanks a lot, Maria Luisa. So I suggest that we move to the next speaker. So Patrizio, if you like.
Thank you, Simon.
Thank you.
Thank you very much. My name is Patrizio Salice. I'm a researcher at NOVAMONT, and I'm here to talk to you about the bioproducts from urban waste that are a huge opportunity for the bioplastic industry. But first of all, a few words about NOVAMONT. NOVAMONT is a certified benefit corporation. We are the international leader in the bioplastic sector, and we produce and develop bioproducts and biochemical through the integration of chemistry, environment, and agriculture. Our common target is to pursue the territorial regeneration through the promotion of circular bioeconomy models. And we'll see how we are doing that in Circular Biocarbon flagship project by the Bio-Based Industry Joint Undertaking. Our three pillars in NOVAMONT are the regeneration of the industrialized sites, the integration of agricultural value chains, and bio-waste reuse in order to recover useful carbon. And then the final products should be conceived as solution and not as drop-in to conventional non-biodegradable products. We are an international company, which our products are obtained in Italy and are commercialized in most part of the world. Our turnover is above 400 million euro, and we employ more than 600 employees. Of these, more than 20% of the people are dedicated to research and innovation actions. We have also 5 technologies that are first in the world, and that has helped us in order to integrate vertically all our processes from the products up to the feedstock. Let me just explain a little bit this complex slide. Our product, as we will see, are known as trademark Matter B, and these are biodegradable and bio-based bioproducts. These are obtained through technology that include the complexation of starch, the production of polyesters, and the production of monomers such as decarboxylic acids, and the production of, and also, of course, bio-based 1,4-BDO from sugars, and the production of other biochemicals. All these products come from a feedstock, but what kind of feedstock are available to us? Well, we have both feedstock from oleaginous dry crops. These are innovative, sustainable crops that do not use too much water and fertilizer in order to grow. But we have also invested a lot in the use of bio-wastes, such as urban bio-waste, in order, and also agro-industrial waste, in order to obtain all of these material through our own proprietary processes. Our trademark material is known as Matter B. This is a large family of biodegradable and bio-based products. And when I told to you about bio-based, I refer to the origin of this material, and when talking to you about biodegradability, I'm talking about the end of life. All our products are controlled and are certified according to European standards and are industrially compostable. Some of these are uncompostable and also biodegradable in soil and marine environment. Our products are solutions to specific environmental problems and provide an added value both during the use and at the end of their life. Let me give you a panorama of our application. We provide materials mainly for film blowing technology that goes into secondary packaging, bags for organic waste collection, biodegradable in soil mulch films, food packaging and food services as well. And in order to understand why all the effort in obtaining these products as solution, I'm going to show you this slide where you can see that since the 90s, we have implemented at industrial scale a model where in order to improve the collection of organic waste and separate that from landfilling, we provide compostable bags to the municipalities, both small and large municipality, that implement system for door-to-door conversion in order to obtain a really pure organic waste fraction that is then converted into fertile compost used by farmers in agriculture nearby the city where the compost is produced. And now Italy, since the introduction of a 2011 law for the reduction of disposable bags, has achieved 2 huge objectives. First one, we are the first in Europe, in Italy, to recycle food waste. More than 47% of food waste is recovered in Italy against a mean of 16% in Europe. And also, this is a little bit counteractive because I'm telling you that we have introduced compostable bags to recover organic fraction, but indeed, due to the fact that we have created awareness about this sustainable solution, the actual consumption of single-use disposable bags in Italy is decreased. And we have seen a reduction of 58% since 2010 because the people, the final consumer, are more aware about sustainable solution, reusable bags, and just use single-use bags for collecting organic waste. This is another really interesting case from Milan. Milan is a multi-million inhabitant city in Italy, where we have been working since 2011 and even before to develop an industrial model to separate the organic fraction. And you can see that this blue part of the histogram refers to the food waste that is separated from landfilling, is converted into compost, fertile compost. And you see that just in 4 years, due to the collaboration with really smart waste management operators, the municipality, and the introduction of compostable bags by NOVAMONT, the waste fraction collected has increased dramatically. And nowadays in Milano, more than 100 kilograms of food waste per person is collected with a purity above 95%. That generate it's not reported here, but several tens of thousands of tons per year of compost to be used in Pianura Padana for growing crops. Why circular biocarbon? Because I've told you up to now we are using this really pure organic fraction in order to obtain a compost, but there is an even higher value in this organic fraction due to the presence of really pure carbon, and that is to use the technology developed in the Circular Biocarbon BBI-JU flagship in order to obtain novel biomaterials with even higher added value, such as biodegradable and compostable bags for organic waste collection and biodegradable and soil mulch films. How we are going to do that? Well, within this flagship project, we are going to use the organic fraction of municipal solid waste in order to obtain a biodegradable biopolymer that once combined with NOVAMONT biopolyester, it will provide biomaterials for compostable bags and also for biodegradable and soil mulch films. These are application that has been developed by NOVAMONT since tens of years. It's been already validated with the use of these novel polydroxyalkanoate polymers. But in this case, we're going to obtain that from the organic fraction. What are the benefits? First of all, we are demonstrating that the organic fraction from the municipality have a high added value, and we are demonstrating a circular bioeconomy case where the compostable bags are reused in the collection of organic waste, closing the loop in this urban cycle. But also, we are interconnecting the urban dimension with the agriculture surroundings and framework, since we are using our urban waste in order to generate a product, not just compost, but also biodegradable and soil mulch films that are really valorizable from the farmers around the city. As I mentioned to you, we are an international company, and we are not only focused in Italy. Indeed, let me just tell you that within the Friendship Flagship, another European project, we are implementing a similar model in the Lockie region of Poland that will be then transferred also to other European countries like Netherlands, Portugal, and Greece. I would recommend you also to follow the progresses in the Friendship program. Let me conclude this short presentation with this slide. Please connect to the Circular Biocarbon project because there will be exciting news and results in the coming years. And thank you very much for your attention.
Excellent. Thanks a lot, Patrizio, for this really interesting presentation. Do we have any questions from the audience? No. Maybe one question that came to mind is, Patrizio, you presented the different feedstocks that you're using, and I'm pretty pleased to see that you're using a lot of waste and scrap to manufacture those biomaterials. Would you be able to explain what would be the share of oleaginous crops and the share of waste and scraps that you're using, roughly?
Thank you for the question, Simon. This is a really complex question to be answered because, as you clearly know, when it comes to use agricultural waste, we have to tackle the seasonability of the growth of the crops, how to collect them and transport them. Indeed, these are available specifically around certain time of the years. And while, for example, when we comes to use agro-industrial waste, such as exhausted frying oil, used cooking oils, for example, there is not, the seasonability is kind of, let me say, we do not feel that much of seasonability. And that tells us that during the year, we have the possibility to adjust what could be the feedstock introduced within our processes in order to obtain the final materials. But let me be clear, some of these products are unfortunately highly regulated, and they are not so available in quantity, despite the fact that they have really high purity and they could be used in industrial processes. And that comes to what already Maria Luisa told us about. Yes, there is a quite heavy normative framework, which is really useful when it comes to contaminated wastes. But let's remember that some of these wastes are really pure, but need to be treated as waste and could not be used unless there are some really long end-of-waste procedures at the national and European level. So we really hope that in the coming years there will be a specific regulatory framework that can enable the use of really pure wasted in order to obtain high-value bioproducts and biochemical from Europe.
Great, thanks a lot. So I suggest that we move to the last presentation. So Johan, if you like, the floor is yours.
Perfect, thank you very much. I will share my screen in a moment.
The sound is a bit low. Maybe if you like to...
Now it's better?
Slightly better.
Oh, I don't know what else to do.
Well, we'll turn the volume up then.
Okay, do you see my screen?
Yes, we do.
Perfect. So let's start with a presentation, which is entitled Sustainability Approaches of Circular Biocarbon Biorefineries. The presentation is divided in 4 sections. First, very quick introduction of myself, and then as the project has started just a few months ago, there is no data that I can share about sustainability results of the circular biocarbon product. So the idea is to share a little bit with you what is happening right now at EU level and what we are going to do and what we expect during the project, but without any specific result because the biorefineries are still under construction. So we will start with a very brief overview of the current organic fraction of municipal solid waste treatment and sewage sludge treatment in Europe. Then how we are going to approach the sustainability assessment in circular biocarbon, and finally what we can expect. So a little bit of myself, as I'm already been introduced, I will just say that I'm part of the Beta Scientific Coordinator, the head of the Sustainability Accounting and Optimization Research Unit at the Beta Technological Center. And our research is mainly related to life cycle assessment and sustainability assessment in general, but also in monitoring gases emissions and greenhouse gases emissions of different waste treatment technologies. So starting a little bit on what is the current status of the organic fraction of municipal solid waste treatment in Europe, you can see that more or less, in average, around 500 kilograms of municipal solid waste per capita are generated during the year. And from that, more or less around 30%, depends on the country a little bit more or a little bit less, but in general, we can consider more or less 155 kilograms of organic fraction of municipal solid waste per capita per year. If we work a little bit with those numbers, taking into account the general European population, we end up that the total production in Europe on a yearly basis is around 65 million tons of organic fraction of municipal solid waste. And how we are dealing with this organic matter. So as you can see in the chart of the slide, only more or less about half of the, or a little bit more of a half of the total organic fraction of municipal solid waste is, let's say, correctly treated in composting or anaerobic digestion processes, but there is up to 65 kilograms per person per year that are not properly managed, which is, in my opinion, quite a lot. And this amount of organic fraction is going or either to landfill or incineration. Maybe later on we can discuss a little bit if incineration could be partially a good solution or not, but in general, I think it's quite accepted that at least for organic matter, it's really bad solution for the municipal solid waste in general, or plastics or other products with higher low heating value. Maybe it makes sense, but I think we can agree that incineration, even with energy recovery of organic matter, it's a quite bad solution. But so this is the general situation of the organic fraction of municipal solid waste, which means there is quite a lot of room for improvement. If we move to the sewage sludge, again, we face a similar situation, more or less at European level. More than 10 million tons of sewage sludge are generated annually, and this number is increasing every year because every year more towns, especially small towns, are required to have wastewater treatment plants ongoing. So this number is increasing every year. And as you can see, the situation is quite similar. In that case, I would say the sewage sludge is mostly applied to agriculture and compost, and a little bit less on landfill and incineration. But what can happen in the coming years is that the new regulations can hamper the use of sewage sludge in agriculture because of, as in the previous presentation, we're talking about the presence of antibiotics or other contaminants in the sewage sludge. So maybe in a short-term future, this is not allowed anymore. If we don't do something, the amount of sewage sludge that will end up in landfills or incinerations will increase quite dramatically. So again, we face a similar situation with quite a lot of room for improvement. When we think about what are the current treatments and what is the impact generated with the three main options that we have, either landfill or incineration or composting or anaerobic digestion of organic matter, either organic fraction of municipal solid waste, but similar situation can happen with the sewage sludge. We get more or less the numbers that you see in the slide. Of course, the worst case scenario, it's always for the landfill. It does not make, of course, any sense to use landfill as a treatment, even with energy recovery. So the numbers that you see in the slide, from 275 up to 700 kilograms of CO2 equivalent per ton, are mainly related of the amount of gas recovered and valorized to produce energy. So, for example, considering around 60% of landfill gas recovery, you get values close to this 275, and with no recovery, you get values up to 700 kilograms of CO2 per ton of organic fraction of municipal solid waste. For the incineration, again, values can change quite a lot, and this depends also a lot on if there is energy recovery or not, but also on the final moisture or the initial moisture of the feedstock. Because depending on the feedstock, you don't recover almost any energy, and on the contrary, you need to use quite a lot of natural gas or another fuel source to be able to incinerate the organic matter. So normally will be in the higher range of CO2 emissions. But it is true that if the organic matter is mixed with other materials, you can get pretty good results in terms of carbon emissions. Then there is another huge range of environmental impacts that today we are not going to talk about, but they are also there. And finally, for composting and anaerobic digestion, you also have a different range of emissions. Of course, the lower emissions are related to the anaerobic digestion process because there is an energy recovery in form of heat or electricity, and the higher emissions are related to composting, and also depending on the composting technology that you use. For example, it's very different if you are using composting tunnels with gaseous treatments or just static piles with further gaseous emissions treatments. The amount of emissions can vary quite a lot. But again, up to now, of course, this is the best way to treat these organic wastes. And it is important to highlight that using composting or anaerobic digestion, we create a product that can be valorized as the compost or the digested, which is quite useful, at least, for example, in the Mediterranean regions in which the soil organic carbon is quite low. But the idea of circular biocarbon is, okay, can we do better to just recover compost or digestate? What happens with the product that cannot be applied in the field? What we do with them? So the idea of circular biocarbon is to try to implement these technologies then that can provide higher added value products rather than compost. But again, of course, to produce these products, we will need new technologies that will consume resources, that will consume energy, that will consume chemicals, and so on. So this needs to be assessed in the overall perspective, not only the benefits, but also the drawbacks of these potential technologies. So this is where it comes, the sustainability assessment of circular biocarbon by refineries. And in the end, we always try to do a holistic assessment, including not only environmental assessment, which is the environmental LCA, but also a social assessment and a techno-economic assessment. In the end, we already know that it doesn't matter how green is a technology or a product. If there is not a real business case behind it, it's not gonna reach the market. So it's very important to develop technologies that really have a business case, a strong business case behind it. Anyway, for the moving to the environmental assessment, what we will do is a life cycle assessment, which I think most of you already know. But in any case, a life cycle assessment, it's an environmental assessment which focuses on assessing all the inputs and outputs of technology through all his life cycle stages. So from the extraction of raw materials to the end of life of the final products. We will do that following two main guidelines. One is the product or organization environmental footprint, which is the main method recommended at this moment by the European Union. But then we will also complement this assessment with other ongoing developments, especially focusing on the type of feedstock that we are using. Someone was also explaining before that it's very different when we are developing these high added value products, the initial feedstock. It's super different in terms of environmental performance. For example, if you are producing a bioplastic or something like that, if you are using, for example, first generation sugars compared to second generation sugars. So the final environmental burdens are completely different. So this is something very important and in favor of the circular biocarbon approach, which mainly use, as you have seen, waste streams. Then again, we will perform a cost-benefit analysis in which we will model all the different technologies and the link between the different technologies in the biorefinery. And in here, what is more important is to assess the sensitivity assessment of the most relevant parameters. For example, right now we are seeing with the energy crisis how a change of energy prices can hamper the profitability of our technologies, or how the market prices can change for good or bad, depending on the overall market situation. For example, we know fertilizer prices change quite a lot on a yearly basis, depending on the climate and so on. So all these variables must be included in a cost-benefit analysis to at least provide a range of certainty of the potential profitability of the system. And finally, we will have a look at the social life cycle assessment. Social life cycle assessment, normally you can approach it from two different perspectives. One more focused at company level and what are the benefits, for example, for the workers of the different stakeholders of the value chain. But in that case, as the biorefinery is something new and under construction, and we don't have a specific data on the workers and on the daily performance of a company implementing these situations, what we think is more relevant is to assess what are the expected benefits that can have at a societal level or at a regional level. So how implementing this circular biocarbon approach or the circularity the circular economy concept in general can improve or can help the European Union to achieve their climate goals or the sustainable development goals. So, for example, calculating the social return on investment, for example, related to the avoidance of carbon emissions and all these things. And finally, the last section is what we can expect of the circular biocarbon. As I said, I cannot present final results today because the production haven't started yet. But for example, we can assume, so what are going to be the main benefits of the project? So in that case, there will be two clear benefits. One, as I explained previously, the treatment of these organic wastes can have a huge impact, especially if you are dealing with them using landfill or incineration. So by promoting the implementation of the circular biocarbon biorefinery concept, we will be able to decrease quite a lot the impacts of the treatment of these streams. But we will also have another benefit, which is that we are producing higher added value products that will substitute currently fossil-based products. So, for example, for every kilogram of fossil-based plastic that is being produced right now, there is an average emission of 2.1 kilograms of CO2. Or for the fertilizers, we will be producing mineral fertilizers that can compete with the conventional mineral fertilizers. And right now, for every kilogram of nitrogen fertilizer that is being produced, that is with a process that requires quite a lot of energy, it's emitting 3.5 kilograms of CO2. So all these emissions will be also avoided because we will be able to put into market these new products coming from secondary secondary feedstocks or even waste streams. But again, the thing that needs to be discovered now or studied now is the net environmental benefit, because of course there is these two clear main advantages, but we still don't know the burdens associated to the production of this new treatment. So how much energy do we need? How much chemicals we will need, or what is going to be the end of life of this product. So this is still not clear, and this is what we are going to be assessing in the coming years. So this is all from my side. Thank you very much. And if there is any question, please feel free.
Thanks a lot, Joan. So it's really interesting. I can see myself. So I'm looking forward to see the results of this research. We've got 5 minutes for questions and answers. So you can ask questions to Joan if you like, but also to previous speakers, Marisa and Patrizio. You can also just make an observation if you like, if you get any experience to share on biorefineries and more generally on how to valorize bio-waste. Oh, I see a question from Yolanda.
Hi, yeah, it's Yolanda again. My question is for Joan. If I have understood properly, in relation to the organic fraction of the municipal solid waste, there are more kilograms per capita composted than those sent to landfill or to incineration. Isn't it a good number? I mean, the amount composted is much more than that landfill or incinerated. Shouldn't we be happy with the numbers?
Well, it depends of what you consider a good target. Of course, let's say that the numbers were 90 kilograms per person per year composted compared to 65 kilograms landfilled or incinerated. Is this a bad number? Well, of course, it's not a bad number and it's much better than 20 years ago. Should we be happy with that? Well, probably we can do better, and I think we should aim to do better in the next 20 years. So we are on a good path, but I don't think we can be happy or proud of it. At least the path is good, but I think what we need to do is to keep working on that and to not just think, okay, we are good.
Thank you.
Now.
Thank you.
Thanks a lot, Johan. So I see a question from the audience from Ravi. So you can ask your question directly if you like, Ravi.
Yeah, thank you. Hi, Joe. This is directed towards Joan, but anybody else can also generally comment. Because of the surging prices of natural gas, is there any drive right now to do a lot of anaerobic digestion and creating biogas? Do you see that on the ground?
Definitely. I don't really know all over Europe, but at least I know a little bit better the case of Spain and in particular in Catalonia, where we are located. And in fact, all the governments that we know are starting to plan, or at least planning how the anaerobic digestion could be an energy vector in the coming years. So I think definitely this is happening, and definitely, especially in the Mediterranean countries, I think we are quite below compared to other European countries. For example, Germany has an anaerobic digestion potential much bigger than us. So of course there is countries with more room for improvement than others. But I think definitely this is happening. Not only biogas, but also biogas upgrading to methane, pure methane that can be injected in the natural gas grid. Definitely. So this is coming, and I don't think there is any doubt that it's going to increase in the coming years, for sure.
If I may add something, let me say that from the point of view of the bioplastic industry, the anaerobic digestion of streams, for example, from the fermentation are already being employed in order to recover some of the energy potential that are needed in industrial processes for the manufacture of biochemicals and bioproducts. Indeed, at NOVAMONT, we use the waste streams that come from the fermentation of 1,4-bio-BDO from sugars in order to obtain biogas and biomethane that are indeed used toward our shift in zero waste and full energy independent processes.
So it means that you're using your own biogas to kind of fuel the production process?
In part, yes, and also we are exploring the use. You produce biogas. That means that you can separate biomethane and biogenic CO2. We are also exploring how to use that biogenic CO2 in order to recover that carbon into high-value product. For example, in the Cosmos and Vivaldi European projects.
Excellent, thanks. So we are approaching the end of this webinar. So I'd like to thanks all the speakers for their really interesting presentations. So thank you, Marisa, thank you, Patrizio, and thank you, Johan. I'd like to remind the audience that the Circular Week is still running until the end of the week, basically, so until Sunday. I can share the schedule with you. I'm pretty sure that you will find many interesting webinars and events. I also like to mention that Circular Biocarbon will be present at the EU Bioeconomy Conference that is taking place this afternoon, but also at two different events, Ecomundo and Composiforum, that are taking place soon. I can share the links with you. So the Ecomundo is in Rimini in Italy, and Composiforum is in Spain. And last but not least, if you're interested in biocarbon, stay tuned. We will have some interesting results to share with you in the coming years on the biorefinery, on the sustainability and the biorefinery. So if you'd like to know more, please visit our website, stay tuned on social media, and I will be pleased in the coming years to share the results of the project with you. So thank you very much for attending this webinar, and I wish you all a good week and a good weekend. Thanks a lot. And so, yeah, I forgot, the recording will be made available on the website, so you'll be able to rewatch it and also watch the introduction video that the sound had an issue, and you'll be able to watch it with the sound, which is better always. Thank you, everyone.
Thank you. Bye.